Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. Today I will try to discuss a very important topic, mainly how we can easily find out the coastal chains detection using Google Earth Engine. So basically in this time I will try to explain about that how we can easily find out the sea level rise, impact assessment or coastal erosion monitoring, shoreline chains detection. So this type of things how we can easily monitor using remote sensing technique in Google Earth Engine. So I hope you can easily get the idea from this tutorial. So first of all, we need to detect about our data. So which data you want to work. So we can easily use the satellite data set for coastal chains detection. Mainly you can use it at the Landsat. It's freely available. Sentinel-2, it's freely available. Or MODIS satellite imagery, it's freely available for daily, for long-term analysis. We can easily use the MODIS, as well as also we can use here the Sentinel-1 SAR data, or also you can use some high resolution, suppose planet scope satellite imagery or lighter satellite imagery for the topographical change detection. So you can use different types of satellite imagery. So first of all, I need to import a satellite imagery. So in this case, you can easily use the Landsat, Sentinel, MODIS. So all of satellite imagery you can easily access from the Earth Engine public data catalog. So this is the link. So you can easily get about that Landsat, Sentinel, MODIS. So all of those are the same process when you work. So in this case, suppose I want to work for MODIS surface reflectance satellite imagery. So just I simply click on the MODIS. So now it appeared all of MODIS image collection for the different types of MODIS product. We can easily find out from here. So let's go. We try to use it, and further we try to make the change detection using remote sensing technique in Google Earth Engine. So first of all, let me just simply select my study area. Suppose I want to take this study area of the coastal land of Bangladesh. So then we can easily compare this coastal land, how much land is increased for the different time period. We also try to calculate from here and also visualize how much new land we find out between this time period. Suppose 2000 to 2025, from this time period, how much new land increased in this land, in the coastal land in Bangladesh. We try to identify this type of land easily. So first of all, just simply draw your study area. Suppose I take this study area, look like that. Suppose this is my study area. So just I simply create a rectangle, look like that. And if I just simply, you can see, just I put, okay. So this is my study area. So for this study area, I want to compare. I want to make the change detection. Suppose year of 2000 to 2000, suppose 23 or 25, between this time period, and also compare that between this time period how much new land we find out, how much new land deposition in here. So this type of things today I discuss about that. So let's go try to discuss about that all of process step by step. So in this case, I try to use for MODIS. MODIS basically moderate resolution imaging spectroradiometer. So this satellite image I want to use, and further we try to calculate NDWI. Mainly we try to focus the water body, find out the water body. Okay, so you can use the other types of indices such as MNDWI or NDWI or automatic water restriction. So different types of things we can easily apply from here. So let's go. Let me try to find out this satellite imagery, basically MODIS. We try to use in here. So here you can see this is the MODIS data catalog. So from this MODIS, I want to use the data set. Suppose you can see this data, we find out this type of data. Okay, this is the daily product, travel vegetation, continuous fields, yearly global 250 meter. It's not net. I want to use for satellite imagery, mainly surface reflectance satellite imagery. I try to use in here. So let me find out this star surface reflectance global. Star surface reflectance daily global 250 resolution. Suppose I want to use this satellite imagery. So this is the one kind of satellite imagery for MODIS. It provides the MODIS. So you click on here, you can get all of information. So this satellite imagery I want to use in here. and further I want to monitor suppose NDWI for the different time period. Okay, so this is satellite imagery. If you check, it also have the scale. So this type of scale we need to use for get the proper spectral signature value from the band 1 and band 2. So this satellite imagery I want to use, and further I want to make the change detection between the coastal land, how much land increase or how much land decrease for a specific time period. We try to discuss about that. So let's go try to import this image collection. Just copy this image collection and then paste in your code editor. Then just give a variable name. Suppose I put the variable name is that suppose modis. Okay, you can put any name as a variable. I put this variable name is the modis. So this is my image collection. So this image collection I need to filter for a specific time period. Okay, as well as also need to filter for a specific boundary. So let's go try to do it. So first of all, just put your time period. Suppose I put the time period filter date and put the time period. Suppose you can see this image is available from year of 2000 mainly with 24th February. So I take this data, suppose year of 2001. Okay, I take the whole year. Suppose 2001 1st January from year of 2001 December 31. So now let's check how much image we find out between this time period. Just use here the print and call this modis and use here the size function. So now it's computing. Okay, so for this year of 2001, how much images are available we find out in here. So now it's computing this number of total image collection. So we find out the total 347 image collection we find out. If you want, you can also use here the, suppose I put the modis, it's a 2001. You can put any name as a variable. It's not matter anything. So just I put here. Okay. So now it's created the image collection in year of 2001, but I need to create the another image collection for year of 2000, suppose 25 or 20 or 20 or 2024. Okay, so let's go. Just take a variable, suppose modis. I use here 2024 and just call this same image collection and then paste here and then filter, just filter it. Use here the filter date function. So these things I want to filter year of 2000, suppose 24, 1st January from year of 2024 December 31. So this is my last time period. So now let's check how much image is available for this time period. So just print this variable, print this modis 2024, this variable, just print and use here the size function. Okay, just click on. So now it's computing how much images are available for this year of 2024. We find out that total 365 image collection we find out. Okay, 365 image collection is available between this time period 2024. So now in this case, I want to calculate the NDWI, and this I want to connect with this two image collection. Okay, further we just calculate the median and then it will be okay. So let's go try to create a function. Okay, so create a function to calculate the NDWI. Okay, so we already know about that, how we can easily create a function. So just I write the function. Suppose put the function variable name is that, suppose NDWI, and then put the function keyword, and then put the element name, suppose img, image, and now just put the curly bracket. In this curly bracket, just put your argument. So actually, what is my argument? My argument is that I want to calculate the NDWI using the modis satellite imagery. If you check it, basically this is the band. We find out the surface reflectance band 1 and surface reflectance band 2. And furthermore, this formula is that surface reflectance band 1 minus surface reflectance band 2 divided by surface reflectance band 1 plus surface reflectance band 2. Then we can easily find out that NDWI. So let's go try to use it in this code. So for that, just take a variable. I put the variable name, suppose just take the variable name, suppose bands. Okay, and first of all, you can see this type of bands. If you want, you can also do it easily. Suppose I put here the NDWI. Okay, then just call this element name and apply here the normalized difference between two band. First band is surface reflectance B1, just copy and paste here. Second band is the surface reflectance band 2, just copy and paste here. Okay, so just we simply do it, and after that if you just simply rename it, suppose just put here the rename and rename it. I put it's a NDWI. You can put any name. I put this NDWI. So now I just put my equation. So this equation mainly calculate the NDWI, but these things is also need to reclassify. Basically, we need to rescale this type of, just use this value and rescale. So these things you can also do in here. Suppose I just take a variable. Suppose I put the variable name is that bands, and then just make a, then call the element name and select the bands. In this case, this is my band. So basically two bands I have. Just I copy this two band and then make a list in here and then paste this two band. Okay, and further just simply multiply. So just use here the multiply function and multiply 0.0001. Okay, and then further I want to calculate this NWI using this variable bands. Okay, then it also okay. So at the same time we are just multiply and create this function. And what I return, I want to return from this function as a NDWI. Okay, just a return from here. Okay, so now this is the function we created. So basically this function calculate the NDWI. So this function further I need to connect with my image collection. So for that we already know about that. We need to use here the map function and call this function variable name NDWI. Just I copy and paste here. So now it's calculate the NDWI in here. And not only for the NDWI, I also calculate from here dot median all of images. Just put here the median, and these things I just take the water body. So for that I take the median greater than 0.1. Just put here the GT mainly greater than and put the value 0.1. These same things we can also apply for another image collection year of 2024. Just I copy the same things and paste here. Okay, so now we find out this type of things. If you just check it, okay, now further if you just check and also display. Okay, suppose let me just display this two layer. Just add here map dot add layer and call the mode is 2001. Just copy and paste here. Okay, and these things you also need to clip with the study area. So just use here the clip with the study area mainly ROI. So you can see the geometry. So just put here the geometry. Okay, and further just put here empty. Just put here the empty visualization, and then I put the layer name. It's a modis water, suppose 2001. Okay, so this same code we also need to use in here for this another layer. Just I copy and then paste here, and then call the modis 2024 and then clip with your study area, and further I put the change the layer name 2024. So now let's check what happened. Just I run the code. It's working. we find out this type of two map, basically this type of white color indicating about that water body, and this type of black color indicating about that land. Okay, so if you check it, this is the result for year of 2001, and if you check it, this is the result for 2024. Okay, so you can see in the 2024 we find out there are a lot of land it increased between these two time period. Okay, you can see, okay, it increased a lot of land. Okay, it increase the due to the different types of deposition, we find out this type of new land. Okay, between these two time period, this is the result for 2001 and this is the result for 2024. Okay, so now let's check, we try to check about the change detection, basically where we find out the newly land, we try to identify this type of land and we try to find out the change detection using subtraction. So let's go try to do it for subtraction between these two decade. So for the change detection, just take a variable, I put the variable name, suppose change, and call the change year of 2001, just copy this variable name and just subtract with 2024, just copy and paste this variable. So now we find out that change. So if you check this change layer, just use our map dot add layer and call this change, this variable name, and clip with our study area, which is geometry. Just I clip, and then further just put the blank, I put the random color and put this layer name, suppose I put the variable layer name is the coastline change. Okay, so now try to check it just on the code. So now it create this another layer. Okay, and this layer represent okay change. Okay, we have, okay, so just I copy and paste here. Okay, so now run the code again. So now let's create this another layer which is indicating about the coastline change between this time period 2001 to 2024. We find out that this type of place where the changed and unchanged. Okay, basically this type of white color, we find out the changed. Okay, so this type of place, the basically new deposition of sand or land, we find out, and others this type of color indicating about that not change. Okay. So now we can easily find out the change, this type of place we find out the change between this time period 2001 to 2024. So this is the coastal line change map we already created. So now we just conversion from raster to layer, suppose just convert into marks with this layer, so then it will be look more better. So let's go try to do it. So for that, just take a variable. If you want, you can also use the self marks function, or just take a variable, suppose marks, and then call the change this thing, just use here the update marks with this change, just copy and paste. Okay, then just try to add this new layer. So just use here that map dot add layer and call this marks. Okay, it clip with your study area, clip with geometry, and just I apply here the empty visualization and put this layer name, suppose change marks. So just run the code, so then it look more better visualization. Okay, so let's create this another layer about the change marks layer, we find out. And if you want, you can also take this type of new land as a polygon or vector, then you can easily convert raster to vector for this marks land, then it look more better visualization. And further you can also work with that for other GIS remote sensing project. So for that, just take a variable, suppose I put the variable name is that area land, and then call this marks and apply the reduce two vectors and put all of argument one by one. So first argument is that geometry. So it's the same geometry. I put this variable name. Then scale, it's with the satellite imagery resolution, 250-meter resolution. Just I keep. And then just take only for that union 1. Okay, just I put here the dot union 1 milli. It's our new land. We try to put in here. Okay, so let's go try to add this map dot add layer and call this area land. We just copy and paste here. So now it's create a polygon. Okay, it create this polygon east land. We find out in here. So let me open it. Okay, find out this type of change marks. Okay, so in this time in year of 2001 there was no land. Okay, but in year of 2024 we find out that land. Okay, as well as this type of land we also try to convert as a polygon. Okay, so then we can identify how much new land increased in the coastal land. We find out. So here you can see this type of place. We find out that it's a land, but in year of 2001 there was no land. It's a water body. We find out in here. Okay, this type of place. You can also compare this result. Suppose just open the year of 2001, then you can find out it's just a water. But in 2024 we find out this type of place as a land. It's working. And further this polygon, area land polygon, we also try to convert as a shape file or KML file or KMZ file, and further we can also use it in other geospatial software. So now it's working. It's a big study here, that's why it takes some time. But if you want, you can also take it. Suppose I take work with for a small boundary, so you can see it working. So now we find out this type of place. We find out that change between the 2001 to 2024, but it looks more better if you just try to take the small study area. So you can see we find out this type of place. There was change. We find out. Okay. Also you can see this type of place. Okay. This type of place we find out the land. Okay. We find out this type of place is the land. Okay. And further you can also use it as a polygon. Just simply convert, just simply download as a KML or KMZ file, and then you can also work. Or if you want, you can simply work with any specific island. Suppose just I remove. So now we can see here, we find out this type of result for this study area. We find out it's a water body, white color, and this type of things is the land. We find out. Okay. And further we can easily calculate the change detection, mainly coastal land change, and also calculate this type of thing as a polygon. So now I can see find out this type of place. We find out the change between this time period 2001 to 2024. So now if you check, we find out this type of polygon. It's indicating about that change area between this time period. Okay. And this type of things you can easily export as a shape file, or this type of thing can also export as a raster imagery. And further, you can also make use it for creating this map. Okay. So I hope you can also get this idea how we can easily make the coastal land change detection, as well as it also helpful. This technique can also apply for the different types of work, such as our coastal erosion monitoring or sea level rise impact assessment, also shoreline change detection, okay, mangrove loss monitoring. So this type of things you can also apply the same process. Just take this 2-decade imagery. You can use at the Landsat, Sentinel, or Modis, whatever. The same process you can also apply, and further you can easily do it. So today is no more. Thank you for watching that. Stay happy, stay safe.